Hey there, guys. Well, I'm here to talk about motors for bullet feeders. Since Double Alpha, Mr. Bullet Feeder has pulled their motor off the market for all us guys, it's been a difficult time finding a good motor. The motor they used to supply was perfect, and now we have to do substitutes. And this is one of the styles listed in the files. If you have the files, they were talking about a JGY 730. This one I picked up off Amazon. This is a Gearston. This one is a, will this thing focus? This one is a JSX 950-370. The 370 I know is the motor size itself, but this is the JGY style, and what makes it that is the size of the spacing on the holes itself. For that style, and I'm not even going to give a link to this because they only had a couple of them left. If you look on Amazon and get into I think I punched in worm gear drive motors and you'll get into them, but I wouldn't buy anything without the spec sheet. And what you're looking for here is 18 millimeter by 33 millimeter. That is your important numbers right there, because that is the hole size in the base plate. So that being said, the other problem is, A, this is a 6 millimeter, and B, the length of this thing is way short. The Mr. Bullet Feeder was like an inch long, and it had the pin through it. So we're combating those two things. I printed up a test base. This is done in real low resolution. I just needed the plate to check things out. But if you see, as this comes through, that barely sticks through. That's one problem right there. This being a 6 millimeter is the other problem. The Mr. Bullet Feeder was an 8 millimeter, so all the bases, unless you redraw the bases, you can just see they wobble in there like that. So I started thinking about this whole thing, and luckily I do have a lathe. If you have a lathe or your buddy has a lathe, that'd be the way to go. I just had some 1/2 inch round stock, so I milled up a adapter shaft for it, and so that would just fit over like that, and I put a set screw right there, and that'll tighten up against the flat like that. Now it's good and tight. I mean, that thing does not move except for any movement down here. So the other thing on that is, when I take this off, when I milled this, I made sure it's full round at the bottom, that I came over that, and that gave me extra support. So putting this back on, I tighten this down now, and when I did that, I drilled the hole for the shaft, but I made sure, if you can see, there's a little light right in here, that it didn't bottom out on the base, so it didn't interfere with it. And then the top shaft I milled to 8 millimeter. I put an 1/8 inch piece of music wire in there, and I tapped it with a set screw up top to hold the the crossbar in there. So with that being done, the bottom base, this is a little sloppy. You have to increase this hole because of the thickness of this shaft right here. That sets up another problem right here. Now you're too long. That's easily to be dealt with. I'm just going to 3D some spacers and put them between the motor and the base, and that'll put the put the shoulder just below the base plate itself here. But now, if I can get this thing out, you can see when this thing goes on here and there. Now you can see it's good and tight in there. It might have a little side wobble to it on the pin, but that's acceptable. You're tight on this 8 millimeter. So let me show you what I did with that. So let me take this apart, put this plate aside, and I'll pull this off here. And so this is what I came up with as far as a worksheet on this piece here. So I just started out with that. I just made sure I didn't drill this too deep, so I had a little bit of space between the motor, so it didn't bottom out. But I ended up with 1 inch .193 for overall length. This remains a 1/2 inch at the bottom. I came up .685 to the shoulder, and then I came up .508 there. In between, I left about an 1/8 inch little piece of material here, so this drill hole didn't get into the shaft. I put an 1/8 inch hole up top. This I drilled and tapped for 5 millimeter. I think they call that a .8 pitch on that, because of the hole size. I couldn't go bigger. Maybe a 3/16 would work for you. And so that's pretty much it. That's all my numbers there. The bottom hole worked out really well because I don't have metric bits. 15/64 worked out beautiful for that. It gave it a nice snug fit in the hole itself. The top, I just put a 632 in for the top screw. I have to grind that screw down a little bit so it's flush, and I did the same thing here so it wasn't sticking out. I actually had to take a little bit off of both sides. So that's the setup on that. But that's all my numbers on that, and nothing's etched in stone. This I pretty much just put in the middle of the flat on the shaft. This one you could probably come down a little bit. I didn't give you a number on that. You can just look at it. So I think that's about it for this process, and I'll show you the next process, which was to try to get a centered hole in this thing. This is off a hair, but it's pretty good for what I had in stock as far as tooling. My drill press has a little bit of play into it, but I'll show you that process next. So like I said, if you go to Amazon, pull up Worm Gear drive motors, you'll see a bunch of these. But like I said, I would look for a spec sheet, and really, even if they don't have it drawn out, someplace they'll have 18 by 33. That's what you want. Each of these motors may be a little bit different in length here, so I'm not going to really give you that number because it could vary a little bit. So when you get one, you have to measure it and figure that part out. So all right guys, off to the next step. Okay, we're over the drill press now. The major tool on this is my V-block. This I just made on my router table. I have a 45-degree bit, and I ran this over my router table and it created the V for it. I've used this for many projects and it works great. So what I do for this is, in the drill press right here, is I have a countersink for metal, and what I do for that is I'll bring this down until that point hits right into that tip of that V, and then I'll clamp that down to the table, but really making sure that thing hits right in the center of that V. And from there I would just take a piece of round stock like that. I would come down with this and I would just work this down, and I'd put a decent dimple in it, and then I would swap that out with the drill press itself, and now you have a center for the drill bit to guide into, and that works pretty good. Like I said, my center came off a little bit, but if I wiggle this chuck here, I can feel there's a bit of play in this thing. It's not a precision drill press, so I can live with it off a little bit. I had to file the grooves where the T-pin went through a little bit, but it was totally acceptable. So that was just a router table, 45 bit, and make your own V grooves. It's just an old hunk of oak I had laying around, so I just ran that down And when the end gets boogered up, I just chop off, you know, ½ inch or an inch. It gives me another fresh surface. So that's how I did that. So we'll go on to the next phase. Okay, this is the power supply. I picked this up off Amazon. You just have to do a search. There's a few of them out there. I can't recommend one over another. This is just the one I got. This is actually a 5 amp power supply, and has a readout here, and you know, you'll see your voltage in a readout. Funny thing about this, when you hit about the halfway point on this dial, you are maxed out on voltage, so this other half really doesn't do anything. But you can dial down, once you figure out your speed rate, you can just jot down the voltage and it'll put your motor at the right speed. Like I said, there's several different options out there, but this is just the one I got right here. I don't even know if there's a name on this thing. Yeah, it's a JDT001. Yeah, 3 to 12, and input, so there, 50, 60, and I think it's rated at 5 amps. You don't even need nowhere near that for these little motors. The one thing I did notice when I hooked it up to this, I hooked positive, positive, negative, negative, and then when I fired up the bullet plate, it was rotating the wrong way, so I'm just got to swap the wires around to rotate in the right direction. Not a big deal. So that's that. Okay, I got more to talk about, so let me clean the table and we'll get into the next part. Okay, a few years ago I did a build, and I was messing around. I'm gonna raise this up a little bit. I was messing around with the micro switches for the shutoff for the feeder tube, and they ended up being a royal pain in the neck. So this round, I'm getting ready for a build. I printed out the light tubes, and I'm using the Photocell setup on that. So this is the Photocell. I had to drill these holes out a little bit. They were a little snug. And so that's a little relay unit, and of course I got a ton of wires attached to this. And right here, this is your indicator for your powered up. The green light, that is sensing whether this photocell is receiving light or not. Right down here, if I hold this up for you, right down here, there's a little pot right here with a Phillips head in it. That's your sensitivity control. There, you can see it right there, and you can just get into that with a Phillips screwdriver and adjust the sensitivity to this thing. So this is going to be much easier. Now, I was messing around with this thing earlier, just trying to do ambient light, and really, I thought I made a bad mistake. This is just a low quality print here. I just printed out one in high quality. It turned out nice. So the way this is working, you get this back in the picture here. Right now, it's not sensing any light. Now, I got the sensitivity set pretty high. This way, the ambient light doesn't make this thing kick on and off like crazy. So if I just take my flashlight, and you watch that green light there, when it sees the light, that green light goes out. So that's telling you it's, you know, it's making its contact. Now, on the back side of this board right here, you have 3 pins. Center would be your common, and then one side's got to be normally open, one side's got to be normally closed. I'm not sure which one, but that's how that works. On the side of this, it has a little jumper. That jumper where it is right now leaves it just in contact. So if you move that jumper over, you can actually pass power through this, through your power connection. But I'm not doing that. I just want it as a contact. So then I needed a constant 12 volt source. So for that, and I'm just going to unplug it, Anytime I throw out an old cordless phone or something, I keep the power supplies, you know, just throw them on the shelf, and I have one when I need it. So I didn't have to go buy that. So I put that back on, and that's 12 volt. So, and then on these pins, because everything's in Japanese, Chinese, whatever, it says ground right there. Everything else is in a language that I do not know. So as long as you know your ground, the other one's hot. Okay, so like I said, I gave up on ambient light because it would anytime you would pass your hand over it or something, it would just make the thing go wild. So what I came up with is I got some LEDs. My buddy, he brings control boards home from, he does commercial fire pumps, and they have them in there. So I just grabbed one of the circuit boards and desoldered all these things. This is a 5mm, and I didn't know much about these when I started, so I just hooked a 12 volt supply to it. Well, guess what? It's 3 volts, and it went out like a flash bulb. About a second later, gone. So did a little research. I had to run a resistor in it, and I think what they were telling me is I needed like a, I don't know, like a 320 or a 360 resistor. I did have a couple in stock. I had a 560, and that's actually good. You know, keeps the light a little dimmer, so the light doesn't have to work as hard. If this thing will focus for me, and I don't know if I do that. Okay, if you can see right on the side there, there's a little short leg, and then there's kind of one that comes up and makes a little right angle. The little short leg right there, that is the positive, because these things are directional. So that little short point is your positive. So this happened to be a green light. I didn't know how the light would affect this photocenter. You know, some of them could be color sensitive, but that worked out nicely. So once I hooked in, I had a 560 ohm resistor, and like I said, that worked out good. So with that, let's see here, I have red marked right there, so I'll go with that, and I just have to find the other end of, there we go, my connectors here, and there's that. Now you can see that's pretty bright, okay, and that worked out well. So I'm going to disconnect this so I don't bump wires, and I did have to run a drill through this to clean it up a little bit, but now it fits nice and snug. So that presses that in, okay, and we got to get our positive hooked to here, and there's our positive. And once again, as soon as I add light to this, that little green light in the corner is going to go out. So as soon as I hit that, see it? Okay, so we got that, and you know, I tested it, I stood it up, I dropped bullets in there, and you know, once it hits that light, it works beautiful. No futzing around with the tang on the micro switch. So I got a dowel right here. I'm just going to feed it through the bottom. It doesn't matter which way it goes. And as soon as I break that light beam, you will see that that comes on. So I just have to determine which terminals to hook up here for my motor connection. So that's pretty much it. Now they had a bunch of these on Amazon too. Once again, it's dealer's choice. When I got this, everything I got, it was like only one left or something like that. So if you do some searching, you'll find them. You know, I don't know if there's any markings on this thing that will help you out here, but you know, it's 12 volt. It does say it's rated for 10 amps. So if you had a bigger power supply, you could feed 10 amps through this thing with that jumper. So, and this end here, that's 5mm also. So that's going to be my next project, is getting this all nicely wired and everything. But I just have to run 2 plugs now because one's variable, and that doesn't make the circuit board very happy being variable. So I did print out the final tube, and that turned out nice. So I have to clean up. Funny thing about the 9mm tube is it's rated for a 9mm, but you go to drop a 9mm through there and it will not go through. The hole's too small in the middle. So I ended up drilling this one out with the appropriate drill bit, and then they drop through. A little extra space, but that's okay. You need some room for them. So that's pretty much in the whole thing. You just have to do a little bit of searching for your power supply and your motor. And if you want to go with this route, check one of these photo sensors out. And I think this would be a nice addition. I'll print out a nice little box for it and all that stuff. So right now I'm printing out the base, and that's got many more hours to complete. But I just wanted to pass this on. This setup works really nice. Like I said, you just have to have access to a lathe, and it makes it good again. So all right guys, that's my my advice on all this stuff, and maybe when I get this thing made up, I'll show it to you. So all right guys, take care now.